This video is for a project, project 3 for my Scientific Methods course, HMT2, and this is Paul Anderson. So the project was to talk about technology and how it can be used to help students analyze or learn more information and gain a better understanding. And so the task that I came up with was to look at a collision, and we have a video analysis of that collision. So what I'm using is a program called Logger Pro, and I'm actually then currently grabbing the video that we took of two Hot Wheels cars undergoing a collision. And so here's our file, and it's a high-speed video taken with a camera that is at, I believe, 80 frames a second. So we can go ahead and do a quick little play of this video to kind of show what it is looking at. And so you can see that the two cars collided, and eventually friction slows both cars down. So that would be one of the points that you need to talk about. To utilize the software, we can just turn on our tools and go back to the beginning, and we'll play the video until we see the first blue car coming in. Okay, so now we have the blue car coming in, so we're going to now track some of these with using some data points. And so I'm going to go ahead and plot a point here for the blue car, and then I'm going to advance about 3 frames, or 1, 2, 3, 4, 5 frames, and then I'm going to put another dot, and I'm just getting enough information, 1, 2, 3, 4, 5, so that I can get what the 3, 4, 5 speed of the blue car is before impact. 1, 2, 3, 4, 5, and there's our speed right before impact. Now what we're going to do is we're going to get through the impact, so we want to move after the collision is broke free. So there we have broke free. Now we're going to do plots on the silver car after the collision. 1, 2, 3, and the silver car moved a little slower, so I'm going to go 3 frames in between. And really, the number of frames that I go in between doesn't matter. I could put dots for every frame, but I just need to get enough so that I can get what the speed of the cars are. Okay. And so now I've kind of set that up. I can go through and set a scale here. Setting a scale allows me to know how fast something's going, so I have to have a known distance, and I know from that end of the track to that screw head is 18 centimeters. Okay, so I've scaled that. I can put an origin on here, so we can put the origin there, and now we have our video kind of analyzed, and we'll now do a quick auto arrange so that we can see what our points look like. I'm not interested in the Y component, so the Y components, I'm going to get rid of that and just look at the X components. And now I'm going to set up and do a time frame. I need to readjust my options on my movie. So on my movie options, I'm going to first of all override this so that we know that it's 80 frames a second. We're going to set our first time point at 0. So now we've actually got our points that represent the blue car. We've got our points that represent our silver car. So before the collision, we can do a linear fit of this data. And that'll give us our speed of our first car. We can also do a linear fit of our other data, and that'll give us the speed of the other car. So we can see that between the speeds that we collected and the masses of the car, we should easily be able to calculate our momentum of the car before and the momentum of the second car after. We'd have to insert another video to do the analysis to get that. But overall, the tool itself to do video analysis will be a great way for kids to understand how to generate a speed, and they can see visually what's going on as well. So even like when I go back here, we can see that this is the point in the video where the car is moving before the collision, then this is where our car is moving after the collision as well. All right, so that should be my description now of the tool itself that we're using, and I'll go back to the report to give my comments on what I think the findings